Today we're going to be talking about polynomial long division, and so we're going to first off start by relating this back to the division that you're already familiar with. So we're going to talk about long division for just a moment. So you remember from elementary school, whenever you would divide things like 15 divided by 3, you had parts to your division problem. This number right here, the 15, is called the dividend. The number outside is called the divisor. And the answer to your division problem is called your quotient. Okay, I also want you to recall some things that we learned about multiplying polynomials that will help you as you work through the division of your polynomials. So if you remember, whenever we multiply polynomials like 3x times 2x, you will multiply the coefficients, and 3 times 2 is 6. X times x becomes x squared. So understanding how multiplication works, you can see that if you were to go backwards, that 6x squared could be divided by 2x, and the quotient would be 3x. So just from what you've learned from fact families, you can see that this would make sense. So we're going to use this same idea as we work down to these problems where we have polynomials, which may possibly be monomials like 3x, or binomials where there are 2 terms. And we may even get a little bit larger with our problems and get down to trinomials like you see here. So to start off with, let's identify that this first polynomial is going to be our dividend. The second polynomial right here, the 3x, is going to be our divisor. And we're going to set this up basically whenever it's a simple one like this with a monomial, we don't necessarily have to use the long division. So what we're going to do is we're going to set this one up in a more simple way, and then we're going to move into using long division. So what you have here is you have 6x squared plus 12x, and the entire binomial is being divided by 3x. So oftentimes we split this up, and we take the first term and divide it by 3x, and we take the second term and we divide it by 3x. Now you guys may recognize this from when we used to circle these together whenever we would have problems like 6x plus 2 divided by 2, and we would divide the 2 out of the first term and the 2 out of the second term. Well, we're going to do the same thing. We're going to divide the 3x out of the first term and the 3x out of the second term, which results in these two monomials that you see right here. Okay, so when we have 6x squared divided by 3x, we're going to divide our coefficients, and we get 2. And then x squared divided by x, going back to our exponent rules, we know that whenever you divide exponents, you actually subtract them. So we're going to do 2 minus 1. And so this is going to be x, because 2 minus 1 is 1. And then when you do 12x divided by 3x, 12 divided by 3 is 4. X divided by x just makes 1 whole. So it's like 4 times 1, and we don't really have to have the 4 there. So we can just cross that out, and our result is 2x plus 4. Now moving over here to the second problem, example 2. Whenever you're dividing a binomial by a binomial, it gets a little bit trickier, so we're going to use our long division. So we're going to take our dividend, and it's going to be divided by the divisor right here, which is x plus 1. This one's a little bit trickier. We're going to write the dividend first, and just like we would normally do, we're going to put that under the bar. Outside, we're going to put the x plus 1. Okay, so we're trying to see how many groups of x plus 1 would there be in 4x plus 5. Okay, so your first step whenever you're working out a problem like this is going to be to go ahead and recognize that you're going to take your first term, which is an x, and you're going to put it into the first term of the dividend. So we're going to ask ourselves, how many times would x go into 4x? And x times 4 would make 4x, so that means that x will fit into 4x 4 times. And if you think about the number 4, it does not have a variable on it. So whenever we write it up here in the quotient, it's going to sit above the 5 because it is another constant term. So we're going to put the 4 up here because 4 times x makes 4x. And then we're going to multiply, just like distribution. 4 times x is 4x. 4 times 1 is 4, and it's positive. Okay? Now this is another little tricky part. Okay, so what you're going to do now is we know that whenever we work with division, when we get to this step, just like we did up here, we subtracted 15. Okay, to see what we have remaining. So we're going to have to subtract what we just did, but when we subtract a binomial, that negative distributes out, and it turns this 4x into what looks like a negative 4x, and it turns this positive 4 into a negative 4. So now we're going to go ahead and do our subtraction. So now what we have really is 5 minus 4, which is 1. And we have 4x minus 4x, which is 0x. All right, now this seems a little awkward when we have these variables in there, but this is how it works. And we don't have to write the 0x now. There's nothing there. It's just holding a place, so we can take that off. We have no other numbers that we need to bring down. So we're actually finished with this problem. So the resulting answer is 4 from what you see up here on top. The remainder is right down here. So what we're going to do is we're going to take that little remainder, we're going to create a fraction with it. So what we have is 4 and then 1 left over out of x plus 1 that we were trying to fit. So what we're going to do is we're going to put the x plus 1 as the denominator of this problem. And so you actually have a fraction with variables in it. Okay, let's try number 3. Okay, number 3 gets a little bit trickier because the problem's a little bit more complicated with the trinomial in there, but we're going to go through the same process. Okay, so we're going to start off with, we're going to put the 6x squared plus 17x plus 20 as our dividend. Then we're going to put our 3x plus 4 as the divisor. And we're going to do just like we did in the second example, and we're going to try to fit the first term into the first term. So you're going to ask yourself, how many times does 3x go into 6x squared? Or what would you multiply by 3x to get 6x squared? And we know that the answer to that is 2x. 3x times 2x would be 6x squared. Okay, so we have 2x, which we're going to place above the 17x since they are like terms. And 2x times 3x makes 6x squared, but we have to continue to distribute and give the 2x out to the 4 as well. 2x times 4 is positive 8x. And then we're going to go ahead and subtract. Now remember, when we subtract, we're subtracting the entire binomial, so this negative is going to distribute and change the signs. So you think of this as a negative 6x squared, and then this negative gives out and makes this 8 turn into a negative 8x. So go ahead and subtract, and 17x minus 8x is 9x. 6x squared minus 6x squared is 0x squared. Remember, this 9 was positive, so we can put that plus sign in front of it if it makes you feel better. And then we notice right here that we actually have something to bring down this time. We have a positive 20 that's going to come down. Now we have no need to keep this 0x squared, so we can just ignore that. And then we're going to continue division in the same manner. We're going to put the 3x into the first term of the remainder that we have right now. So how many times will 3x fit into 9x? 3x times 3 will make 9x. So we're going to put the plus 3 up here at the top, and we're going to distribute again. 3 times 3x is 9x. 3 times 4 is 12. And then we're going to subtract. And recall, when we subtract, we're subtracting the entire binomial, so it's going to make these look like this is a negative, and it's going to distribute out, and it's going to appear like a negative 12 as well. So we have 20 minus 12, which is 8. We have 9 minus 9x, which is 0x. And just like before, we do not need that any longer. We have no more numbers to bring down. Our quotient is complete. And so what we need to do now is just write it. So what we have here is we ended up with 2x plus 3 as a binomial in our quotient. We had a remainder of 8. So what we're going to do is we're going to put a little plus sign right here to show that we had 8 remaining out of 3x plus 4. Now I just noticed, back up here, I forgot to put my plus sign in there, so let's go ahead and do that. So move back up to example 2 and be sure you put your plus sign in between that whole number 4 and the fraction. Now again, this looks very awkward, but this is actually our solution in our polynomial division. Okay, now let's give number 4 a shot. Okay, looking at number 4, we're going to start again with our dividend, which is 3x squared plus 2x plus 15, and we're going to divide by 1 plus x squared. Okay, now one thing that you need to be sure you do is we have to remember these need to be in standard form, so we're going to need to reverse this order here, and so what we're actually going to be dividing is x squared plus 1 as the divisor, and our dividend's already in standard form because it goes x squared and then down to x to the first, and then a term that does not have x's. So now we have it in standard form. That's what we're going to use. All right, so we're going to circle those first terms. We have x squared and 3x squared. Okay, x squared times 3 would make 3x squared. So what we're going to do is we're going to go ahead and put the 3 up here. And the reason we're placing it over here is because it is a constant term. So it needs to be right above the 15. 3 times x squared makes 3x squared. And then we're going to subtract that. That will give us 0x squared. And we're going to bring down the 2x and the plus 15. Now just like before, we no longer need the x squared because there are 0x squareds, but we have 2x plus 15 remaining. Now you'll notice at this point that x squared is actually larger than 2x as far as the degree, so there's no way that x squared can actually go into 2x plus 15, so this means our division is complete. Okay, so this is we're going to stop right here. This is going to be our remainder. And just as we did before, we're going to write this as a quotient. We have a 3. And then our remainder is 2x plus 15. And then we're going to take what we had out here as our divisor, and it's going to become the denominator. So we have x squared plus 1. Okay. So I guess that about does it for us. If you have any questions, be sure that you come and you see me before school, and I will see what I can do to help you out. So let's see. Oh, you know what? I actually just realized I made a mistake in there, guys. No surprise to you, right? Notice right here, I distributed this 3 out to the x squared, but what did I forget to do? I knew this looked awkward. I forgot to give this 3 out to the 1 as well. So if I give the 3 out to the x squared and then I give it out to the 1, I actually have a plus 3 right here where I gave that 3 out. And then what's going to happen is right here, that negative sign is going to turn that to a negative 3. So excuse me, guys, let me fix the remainder here. It's actually 12. So our remainder will be 2x plus 12. So up here in our fraction, we're going to have 3 plus 2x plus 12 over x squared plus 1. Okay, and again, I apologize for that error, guys. If you would just be sure to make sure you have all these copied in your notes and give those a shot as far as understanding them. If you have any other questions, be sure to see me. Thank you.